In this video, we're going to look at the basics of algebra, focusing on the notation that is used. Whilst we will quickly look at why we use algebra, I am going to assume that you have met it a little bit before. In algebra, we use symbols to represent numbers. These are usually letters. The symbols are called variables. Using symbols instead of numbers is great because they may sometimes represent long numbers, and so it saves us having to write them out every time. Like pi, which is 3.14159 and so on, which makes calculating much easier. Instead of writing out the whole numbers every time, we can just say A multiplied by B instead. Much easier. A big reason for using symbols instead of numbers is that the symbols, or variables, can represent unknown quantities, and for showing formulae, like the area of a circle. So let's have a look at some of the key notation. Adding and subtracting stays the same, but instead of writing the multiplication sign, we can remove it and just write AB instead. So if you ever see two letters next to each other, or a number and a letter, then it just means to multiply those things together. Notice how we always use a curly X for the letter X, because otherwise it would look like a multiplication sign. So make sure your X's are curly. So that's adding, subtracting and multiplying. Instead of the division sign, in algebra, we usually write it as a fraction. And then we still use everything else that you've probably come across in arithmetic. Another great habit to get into is to leave numbers as fractions rather than decimals. So 3/8 A rather than 0.375 A. On that note, these mean the exact same thing. You can write it whichever way you prefer. So, there's an introduction to basic algebraic practices. Remember to always use a curly X, that we don't really use a multiplication sign, and that we usually write things as fractions rather than using the division sign.
But before we proceed, please click the subscribe button and like the video, and of course the full bell button so you will be get updated of our.
In this video, we're going to look at how to simplify algebraic expressions. Before we get started on simplifying, a few things to remember. In the algebraic notation video, we discovered that we always use a curly X for the letter. That we don't really use a multiplication sign, so this means 3 multiplied by A, and X multiplied by Y, and instead of using the division sign, we use fractions. Right, so simplifying. In algebra, we are often asked to simplify or to put something in its simplest form. Generally speaking, the simpler it is, the easier it is to use. We just need to combine like terms. So we can combine the A's to get 8A, then the B's, including the sign in front of each term, to get positive 2B, and finally the numbers to get negative 5. We cannot combine different letters, so this is the simplest form. This expression might represent 8 apples and 2 bananas, which are completely different things, so we can't combine them. Can you simplify these 4 things? Don't worry if you aren't sure. Just give them a go and we'll go through the explanations after. Pause the video, try the questions and click play when you're ready. How did you get on? For the first one, we just do 2 multiplied by 3 is 6 and remove the multiplication sign so we get 6xy. In the second one, we group the same letters together. So 2 plus 6 minus 5 gives us 3c. Here, we need to get rid of the multiplication sign, which would give us dd. But we can improve on that even further by writing d squared. If the question had been this, then it would be d cubed. Or this would be d to the power of 4. And then, similar to the second question, we group the same letters together, but they must be the same letter. So 4a subtract 2a is 2a. For division, you can cancel out the numbers exactly as you would with fractions. And we can also cancel out letters. So 10 divided by 2 is 5. And then, because we have 5 a's in the numerator and there are 3 in the denominator, this means we can cancel out 3 of the a's from both the numerator and denominator, leaving just 2 a's in the numerator. And then the same for the b's. We can cancel out 2 b's, leaving just 2 b's in the denominator, giving us our final answer. You don't need to write out all of the letters every time. You can just look at the powers. So 5 subtract 3 leaves 2 on top, and 4 on the bottom subtract 2 leaves 2 on the bottom. So here's some questions for you to do. Pause the video, give them a go, and click play when you're ready. How did you get on? So there are a few different ways of simplifying algebraic expressions. We can also simplify by factoring things into brackets or by expanding brackets. In this video, we're going to look at how to expand double brackets. You should already know how to expand single brackets, but if you've forgotten, you may want to watch this video first. Once we know how to expand double brackets, we'll also be able to expand triple brackets, and so on. So we'll have a look at a triple brackets example towards the end of this video. Let's get started with double brackets. Remember that in algebra, when two things are next to each other, it means they are multiplied. So we need to multiply everything in the second bracket by everything in the first bracket. I'm going to show you two methods, and then you choose whichever one you prefer. For the first method, we draw arcs linking each term. So x multiplied by x is x squared, x multiplied by 3 is 3x, negative 5 multiplied by x is negative 5x, and negative 5 multiplied by positive 3 is negative 15. See how I've ended up with 4 arcs? That's really important because it means I haven't missed anything out. Some people like to remember this as FOIL. First, outer, inner, last. The second method is by splitting up each bracket into a grid. And then just multiply each bit together. X multiplied by x gives x squared. X times negative 5 is negative 5x. 3 times x is 3x. And 3 times negative 5 is negative 15. For both methods, we then just need to simplify the middle terms by adding 3x and negative 5x to get negative 2x. So that's our final answer. So here's one for you to do. Pause the video, expand the brackets and simplify the answer. Click play when you're ready. Did you get it right? Here are 2 more questions for you to do before we look at triple brackets. Pause the video, expand and simplify, and click play when you're ready. How did you get on? For the final answer, it doesn't matter which order you write the terms in. This could also have been written like this. So let's end with triple brackets. They follow the exact same process as double brackets. Start by expanding the first two brackets like you would normally. X squared plus 3x minus 5x minus 15. And simplify it. Now multiply this by the third bracket. Make sure you simplify to get the final answer. Give this triple bracket a go. Pause the video, work out the answer, and click play when you're ready. Did you get it right? So there we have expanding double brackets and even triple brackets. We just need to remember to multiply everything in the second bracket by everything in the first bracket so that we end up with 4 terms. And then we simplify it. In this video, I showed you 2 different methods, so you choose which one you prefer. In this video, we're going to discover how to factorise quadratics. You should already know that quadratics are expressions with x squared as the highest power. We discovered how to factorise into a single bracket in this video, and that factorising and expanding are just the opposites of each other. Factorising still means to put into brackets, but this time we're looking at 2 brackets. Each bracket is a factor. So how do we do this? Let's have a look at an example. Start by putting down your 2 brackets, both with an x at the front, because when they are multiplied together, they will give the x squared. Now look at this number. What multiplies to give -8? 2 and 4 and 1 and 8. Now, which combination of those add to give -2? +2 minus 4 gives us -2. So put those numbers into the brackets. X plus 2, x minus 4. It's really important to check yourself, so just quickly expand the brackets to make sure you factorise correctly. So here's 2 for you to do. I'll leave the steps on screen as a guidance. Pause the video, factorise the quadratics, and click play when you're ready. How'd you get on? So here's one more for you to do, but this time there's no steps to help. Pause the video, factorise the quadratic, and click play when you're ready. Did you get it right? So there we have factorising quadratics when the coefficient in front of the x squared is 1. These are called monic quadratics. If the coefficient in front of the x squared isn't 1, they're called non-monic quadratics. Algebraic fractions are simply fractions with algebraic expressions on the top, on the bottom, or both. We treat them in the exact same way as we would normal fractions. So in this video, we're going to look at simplifying them and also adding and subtracting. In part 2, we'll look at solving. We can simplify by cancelling the numerator and the denominator equally, exactly as we do with numerical fractions. To simplify fully, we may need to factorise either the numerator or the denominator, or both. It might require factorising into 1 bracket, or maybe even factorising a quadratic into 2 brackets. Can you simplify these 2 fractions by factorising first? Pause the video, factorise and then simplify, and click play when you're ready to check. How did you get on? So that's simplifying. To add or subtract algebraic fractions, they need to have the same denominator, just as with normal fractions. Let's have a look at an example. Cross multiply so that both fractions have the same denominator. So we multiply this one by x plus 3, and we multiply this one by x minus 1. As they have the same denominator, we can now add them together. Expand the brackets in the numerator and simplify fully. This is the correct, fully simplified answer. Or you could also write it like this, either one. So here's 2 for you to do. Pause the video, simplify fully and click play when you're ready to check your answers. Did you get them right? So that's simplifying algebraic fractions and adding and subtracting. In part 2, we'll look at solving with algebraic fractions. Again, it doesn't require any new knowledge, just what we already know about fractions and everything we already know about algebra, like factorising. In part 1, we saw how to simplify algebraic fractions and how to add and subtract them. We discovered that they follow the exact same principles as numeric fractions. In this video, we're going to look at how to solve problems involving algebraic fractions. When solving, we could treat them as fractions and make the same denominator to add or subtract. But it's much easier to cross multiply, to get rid of the denominators completely. So this is the method I'll focus on in this video. Let's jump straight in with an example. To get rid of the 3x minus 2 and the x plus 4 denominators, we just need to multiply them both up. We multiply everything by 3x minus 2, but on this side, the multiply by and divide by just cancel out. But do keep in mind for future questions, multiply everything in the question. So now we need to multiply everything by x plus 4. Can you carry on to complete the rest of the question? Pause the video, solve for x and click play when you're ready. Did you get x is 6? Quite often when solving algebraic fractions, we might end up with quadratics, which means we'll get 2 different values of x. So let's have a look at an example. So we start by multiplying up the 2x minus 4 and the 20 minus 2x to both sides. Can you carry on to solve the rest of the question? You'll have to collect everything together onto one side to make a quadratic, which you can then factorise and solve. Pause the video, work out the answer and click play when you're ready to check. Did you get x equals negative 6 and x equals 5? It's really good practice to go back and check your answers by substituting them in. So if we substitute x is 5 into the original question, we get 3 over 6 equals 5 over 10. So a half equals a half, which means 5 is the correct answer. We should also do the same for x is negative 6. So here's one last question for you to do. Remember how I said you must multiply everything by the denominators? Don't forget the negative 1. Pause the video, solve for x and click play when you're ready to check. Did you get x is 3 and x is 2? And did you double check your answers by substituting them into the original question? So there we have solving with algebraic fractions.